Here we are in Chapter 1, Review Exercises with the solutions to number 13 through 27. Number 13, name the number sets that each number fits into natural. Remember, this is 1, 2, 3, 4, and so on. Whole numbers include 0, 1, 2, 3, 4, and so on. Integers include all the negatives, -4, -3, -2, all the way up forever. Rationals are all the fractions, which notice each one of these includes the thing before it, except for irrationals, and these are not fractions, not ratios. And so these are all the scary, ugly looking ones with a non-stopping, non-repeating decimal, and everything is real. So let's do that. So we're going to start with these guys right here. -5/7. Certainly it's real, and it is a fraction, so it's rational. But it is not a negative whole number, so that's all we get out of that one. Number 14, -40, square root of 47. It definitely is real. But it's a square root that doesn't come out nice, so it will never be a fraction. So it is irrational, and we're done. The next one, number 15, -24/3. This is certainly real, and it's a fraction. We can see that it's a fraction. It simplifies, however, to -8. So that means it is an integer, but it is not in the whole or natural number set. Alrighty, number 16, 0. Oh, look, it's right there. So yeah, this is real. Certainly it's a fraction, and it's an integer, and it goes all the way down to be a whole number. All right, number 17. This is -34,285. Hey, there's no decimal or fraction part, so it will go all the way down to being an integer. It is negative, so it's not whole or natural. So it is going to be real, not irrational, rational, and an integer. Correct? Good. Number 18, the number 2. The number 2, well, it's right here in the natural numbers, so it's going to be everything except irrational. So we get it is real, it is a fraction, it is an integer, it is a whole number, and it is a natural number. Excellent. 3 divided by square root of pi, that is definitely a trigger for, yeah, bad news. That is irrational. It is real, and it's irrational. All right, 2.735 with a bar over. That means the 735 repeats a pattern, which means it is definitely rational, but it doesn't go down to an integer. It does have a fractional part, so it is just rational. Okay, so what about number 21? 3.50, 500, 5000. Notice it can't have a bar over it because it doesn't repeat the same pattern over, so it is considered non-repeating. So that means it is irrational. And yes, all of them are real. Excellent. On the next section, evaluate the expression. That means we're going to stick these in. So the -3 goes in for the t, and 4 goes in for the q. So we get -3 squared minus 2q, which is 4, plus 6. That is +9 minus 8 plus 6. That's going to be 7. Good. And the next one, number 23. The 10 goes in for the x, and the 3 goes in for the y. 2/5 times 10 plus 2/3 times 3. 2/5 times 10 is 4. 2/3 times 3 is 2. And we get 6 as an answer. Excellent. This says what are the units. Notice it doesn't actually solve the question. We just want to know the units. Inches, inches squared, inches cubed. And if it's just a length, it's one-dimensional. An area is two-dimensional, like an inch squared, and a volume will be three-dimensional. So in this case, height of a triangle with area measured in inches squared and a base measured in inches, that will be in inches. We're asking for a one-dimensional thing. What is volume of a sphere with radius given in millimeters? It's going to be millimeters. Volume is a three-dimensional object, so it'll be millimeters cubed. Cubic millimeters. What is the lateral surface area? Notice we're doing area of a cylinder, and the height's in yards and the volume's in yards cubed, so it'll be yards, but area is two-dimensional, yards squared. What is the perimeter of an isosceles trapezoid with bases and legs given in feet? Well, perimeter is a one-dimensional object where you're adding up the number of feet around there, so it is indeed feet. Excellent.